So first, I want to say that the quantitative research is the cornerstone of research, so it's very important. And quantitative research with AI tools involves using artificial intelligence to gather, analyze, and interpret numerical data. Why? Because it enhances speed, accuracy, and depth in research. So first, we need to understand, to clarify the differences between qualitative research from quantitative research. Qualitative are two foundational approaches to gathering and analyzing data, each with distinct purposes, methods, and outcomes. So in terms of course, the nature of data, quantitative research deals with numerical data, things that can be measured and counted. On the other hand, qualitative research deals with non-numerical data, interview transcripts, that could be field notes or video recordings. In terms of research objective, quantitative aims to measure, to test hypotheses, establish causal relationships. On the other hand, the qualitative aims to understand meaning, interpret experience, and explore why or how phenomena occur. In terms of methods used here, I will talk about data collection. In quantitative research, we use surveys, experiments, statistics, statistical analysis, modeling, and on the other hand, qualitative observations, open-ended questions, thematic analysis, coding, and narrative analysis. So the role of researcher in quantitative is objective, of course, separate from data, and the qualitative researcher is subjective and often immersed in the content. From the output and presentation, the quantitative research results are expressed as graphs, tables, percentages. The qualitative results are presented as themes, categories, or narratives. For example, how does social media use affect teenagers? In this example, quantitative could be to measure time, the time spent versus the mood scores. And qualitative could be explore personal feelings and reasons. So quantitative research now with AI, it's very useful because machine learning models can analyze large data sets. For example, they can predict sales trends. And on the other hand, qualitative research with AI, we have these techniques which analyze interview texts or customer feedback. So what are essential steps in conducting a quantitative research study? We need to clearly first define the issue or phenomenon that we want to investigate. Ensure that it is specific, measurable, and researchable through quantitative methods. Then we have to review the literature, conduct a thorough review of existing studies related to our topic. This may identify gaps, theories, and variables used in previous research. Then we need the next step to formulate research question hypotheses, develop scientific research questions, and state hypotheses, null and alternative, that can be tested statistically. Then we choose a research design. Of course, we will select a quantitative research design, be descriptive, correlational, experimental, quasi-experimental, and determine whether the study is cross-sectional or longitudinal. Then we define the population and sample. So we need to identify the target population. We decide on the sampling technique, random, stratified, cluster. And we determine the sample size based on statistical power analysis. After we select data collection methods, so we choose appropriate tools, surveys, tests, structured observations, and we ensure the validity and reliability of instruments. The next step, collect the data. So administer instruments in a consistent and ethical manner, monitor data collection, and in order to, of course, ensure accuracy and completeness. Analyze the data, so use statistical software, for example, SPSS, R, Excel, to perform analysis and apply descriptive statistics, mean, median, or the inferential statistics, I-test, ANOVA, regression, etc. Then we interpret the results, so we try to relate findings to the hypothesis and literature and discuss whether the results support or relate our hypothesis. Then we draw the conclusions and make recommendations. So we summarize the key findings and we address implications, limitations, suggest areas for further research. Then we need to report the findings, present results in a structured format. That would be general article or thesis or report, include tables, charts, and graphs to support findings. So how are variables in quantitative research, how they're measured and how they are used? In quantitative research, variables are central to the design, data collection, and analysis process. So how they are defined and measured and used? Variables are defined as a measurable characteristic or properties of individuals, objects, or phenomena that can take on different values. In quantitative research, variables fall into several types. Independent variables, the variable that is manipulated or categorized to observe its effect on another variable. Dependent variables, the outcome or variable being measured affected. Control variables, variables that are kept constant to prevent them from influencing the dependent variable. And extraneous variables, other variables that actually may affect the dependent variable, but they're not the focus of the study. So the measurement variables are measured using operational definitions, specific descriptions of how concepts will be measured in the study. So measurement involves levels of measurement, what will be nominal, ordinal, or interval, or ratio, numeric scales with equal intervals, and the true zero, for example, weight or income. Instruments and tools, surveys, tests, or observation, checklists, and other standardized tools that are used to gather data. And the validity and reliability, we need to know these terms. So what is validity? The extent to which the instrument measures what it claims to measure. And what is reliability? The consistency of this measurement over time. And then variables are used in order to formulate hypotheses. For example, higher study time leads to better exam scores. Guide research design. This determines the type of study, experimental, correlational, analyze data. Statistical methods are used to test relationships and differences between variables and draw conclusions based on the patterns, relationships, or effects observed among variables. For example, does exercise improve mental health? What is the dependent variable here? The frequency of exercise. What is the dependent variable? Score on a mental health scale and measurement. Exercise frequency measured by weekly sessions. Mental health measured by a standardized psychological questionnaire. Now, what are the common data collection tools used in quantitative research? Of course, we have first surveys questionnaires that are structured sets of questions with fixed response. That would be like Likert scales or multiple choice to measure opinions. When we use it to measure opinions, usually to measure behaviors or characteristics across a large group. What is about the high reliability here? There is high reliability if they're well designed, if there is a clear wording, if there are validated scales, and this can be improved by piloting the survey and using standardized instruments. For example, Becker depression inventory or Big Five inventory, etc. The experiments are the control procedures to test the causal relationships between variables. When we use experiments to determine the effect of one variable on another, for example, lab or field experiments, the reliability is very high when internal validity is strong. Control conditions, the control conditions are random assignment. It requires replication, of course, to confirm reliability across contexts. Structured observations, when we have here, it's about predefined categories of behavior which are observed and recorded quantitatively. When we use structured observations, we use them in behavioral studies, the frequency of eye contact, task completion, and what is reliability? It is dependent on inter-rater reliability, the consistency between observers, which is improved through training and detailed coding schemes. The test assessments, the standardized instruments that measure knowledge, skills, psychological traits, which are used usually in education and psychology, and the reliability generally is high. if, of course, they have been validated through psychometric analysis. And this includes measures of test, retest, reliability, internal consistency, and constructor validity. The secondary data analysis, the use of existing data sets, that would be census data, institutional databases, in order to analyze large-scale trends or test a hypothesis without original data collection. So what is the reliability here? It depends. The reliability depends on the original source and data collection methods. Government or institutional data often has high reliability, but limitations exist in terms of control over variables. So here we can see the common uses and reliability factors of each of these tools. And now, how AI now, artificial intelligence, is applied in research process and in particular in quantitative research. Already, we have AI-powered search engines which help researchers find relevant academic articles quickly. Topic modeling and text summarization, automatically we can extract the key themes from hundreds of papers, and citation analysis tools, because many influential papers or gaps, we can map with all these influential papers, all the gaps that exist in research. The hypothesis generation, these models or custom trained systems can summarize vast literature, identify the research gaps, and suggest novel hypotheses. So algorithms like LDA, latent direct allocation, can help uncover themes and trends in existing studies. The experimental design. AI can help design experiments using methods like Bayesian optimization to choose efficient sample sizes or variable combinations. The simulation tools. AI-based simulation can test different experimental designs or help validate assumptions before collecting real data. And what about data collection? We have web scraping bots, which actually they automatically extract large volumes of data from websites. The chatbots, which can conduct surveys and interviews interactively. Computer vision can extract data from images, videos, or scanned documents, and Internet of Things plus with AI. All this can connect real-time data from sensors and connected devices. What about data cleaning and pre-processing? The missing value imputation. AI predicts and fills in missing data more accurately than manual methods. And of course, with anomaly detection, it can identify and remove outliers or errors. Natural language processing converts unstructured text into structured data for quantitative analysis. And data analysis and modeling. What about the AI applications here? Machine learning builds predictive models such as regression or classification or clustering. Deep learning analyzes complex patterns in large data sets, especially in images, audio, sequences. The time series forecasting. Here, AI models can predict future trends based on historical data. And automated statistical analysis, AI tools suggest and run the most appropriate tests. Hypothesis testing, because AI can be used alongside classical tests like t-test or ANOVA test to model residuals or validate assumptions, for example, normality or independence. So augmented statistical tests, bootstrap and resampling, because AI can automate and optimize bootstrapping to derive robust confidence intervals or p-values. The next step is visualization and interpretation, how AI can help us with this step. We have auto-generated dashboards, Power BI, Tableau with AI plugins. Then we can quickly visualize trends and correlations. Explainable AI, this helps interpret complex models in human understandable ways. Language generation models, we can draft summaries, we can result sections or insight explanations from data. The next step is replication and robustness checked, because AI can run massive simulations to test how hypotheses hold under varied conditions or parameter values, and meta-analysis support because NLP can extract structured data from previous studies to automate or accelerate meta-analysis. The next step of the writing and reporting, of course, we have so many amazing tools like Killbot, Grammarly. We can help generate parts of research reports or papers, ensuring clarity, consistency, and even formatting per journal according to general requirements. And automated reporter, code to report frameworks like R Markdown or and other AI tools that can dynamically generate reproducible reports. For publishing, we have these writing assistants, plagiarism checkers, in order to ensure originality and proper referencing, the AI translation tools, which make research accessible in multiple languages. And finally, the last stage, the dissemination impact, how AI helps us. We can track how research is shared and cited across social media, blogs, and news. It helps us with targeted distribution, because AI suggests journals or audiences based on paper content, and voice synthesis or video summarization. This converts research into multimedia content. So for each research stage, we have AI applications. For planning, we have literature with AI can help us with literature mining and topic discovery. For data collection, we have bots, NLP surveys, image or audio data processing. With data pre-processing, AI help us with cleaning, labeling, and formatting. With data analysis, we have machine learning model statistical automation. With interpretation, AI applications are visualization, explainable AI. For writing and reporting, we have text generation, grammar correction. For publication and impact, we have smart distribution, engagement tracking. And for hypothesis testing, bootstrapping, assumption checks. For robustness checks, simulations or meta-analysis tools. For writing or reporting, AI summarization, document tools. So in what ways actually does AI enhance the scalability and efficiency of research projects? We have said that it's about automation because we can automatically collect large volumes of data from diverse sources, websites, or databases, or sensors. So it's about faster processing because AI accelerates data cleaning, transformation, and organization, reducing manual labor. With literature review and analysis, tools like Semantic Scholar or Elicit can quickly synthesize relevant academic papers. So natural language processing models summarize articles, extract key findings, and identify research gaps. With data analysis, we have advanced analytics because AI supports predictive modeling, machine learning, and pattern recognition in large data sets about real-time insights, and algorithms can actually detect trends and anomalies faster than traditional statistical methods. Survey and experiment optimization. We have dynamic questionnaires. AI adapts survey questions based on prior responses, so adaptive learning, and A/B testing automation. In experimental designs, AI can efficiently manage and adjust test conditions in real time. With writing and reporting, these tools can help researchers generate structured drafts. They can edit content, they can create visual data representations, and of course, these tools streamline citation management, ensure academic integrity if we talk about plagiarism checks and formatting. Smart assistants for collaboration. These tools are many AI collaborative tools that can help researchers from different countries to collaborate on the same projects. We can help these tools manage task meetings and research milestones. We can make cross-border collaboration easier through real-time translation, localization tools. And scalability of research applications, because it's about reproducibility. AI pipelines ensure consistent application of methods, making large-scale application feasible, and big data handling, because AI effortlessly scales across vast data sets that would overwhelm manual analysis. So we could say that AI doesn't just speed up research, it also expands what is possible, allowing researchers to handle bigger questions, to handle more data, faster iterations. And in what ways AI does influence the objectivity and reliability of quantitative data? In both positive and negative ways, we could say. Of course, through automated consistent processing, AI applies the same rules across all data, so there is no human tiredness or bias or inconsistencies. What is the impact? This improves reliability by reducing variability in data cleaning, encoding, or classification. Advanced anomaly detection, AI can detect outliers or data errors more efficiently than manual review. So here, this means that it increases data integrity, improving both objectivity and reliability. Reduced human bias. Algorithms may reduce subjective judgment in areas like coding, open-ended responses, or selecting statistical models. So this enhances objectivity, especially in pre-processing and modeling steps. With scalable validation, AI can simulate thousands of test cases or bootstraps to test statistical robustness. What is the impact? That it enhances reliability through reproducible large-scale validation. And explainable AI tools, transparency tools like Lime, for example, or SHAP, allow researchers to understand how predictions are made. So this supports objectivity by revealing internal logic that can be critiqued or validated. On the other hand, now, how can AI threaten objectivity reliability? Because there's always the opposite side. AI learns from data that may already be biased, gender or racial bias in training data. So this undermines objectivity by reinforcing systemic biases under the guise of neutral computation. The lack of transparency, the black box dilemma. The black box is the major challenge of machine learning. What is black box dilemma? Black box means that the machines jump to conclusions, arrive to conclusion without explaining why. So we don't know the internal processes, how these machines jump to this conclusion. So there is a lack of transparency. And this lack of transparency is the major challenge of machine learning and machine learning experts. So the impact here is that this weakens objectivity, as researchers and stakeholders may not fully understand or trust the model's outputs. Overfitting and data snooping. AI can find patterns that can't generalize beyond the sample, especially if they're not carefully validated. So this reduces reliability, making results hard to replicate. And automation without oversight, this means that blind reliance on automated tools may lead to overlooked errors or misinterpretations. So be very careful when we use these tools, because this undermines both objectivity and reliability, especially if outputs are not critically evaluated. Model drift over time. The risk here is that AI models trained on historical data may lead to overlooked errors or misinterpretations. So this undermines, of course, objectivity and reliability, especially if outputs are not critically evaluated. And of course, this compromises reliability unless models are regularly updated and revalidated. So AI models which are trained on historical data may become less reliable as underlying conditions change. So here we have a summary table on this. The consistent automation, what is the effect on objectivity? What is the effect on reliability? This increases, consistent automation increases reliability and objectivity. The bias decreases, explainable models somehow either increase or they neutral, overfitting decreases, simulation-based testing increases, and black box model decreases if they are not explained, so the risk of decreasing reliability. And the human AI collaboration, this depends on design and oversight and validation strategy. So now for data collection and preparation with AI. How can these tools help researchers collect large-scale data efficiently? By automating by accelerating and scaling up the process, especially in studies involving big data or online sources or diverse formats. First, we have web scraping with AI. We have AI bots or crawlers, which can extract structured data from websites, from social media, forums. We have also, I don't know if it's here, smart scrapping tools like Parcel Hub or DeepBot. These tools use machine learning to understand web page layouts and extract specific information. What is the use case? We use these tools in order to collect product reviews or job posting or real-time news articles for analysis. Then natural language processing for text data. This enables researchers to collect and process unstructured textual data from sources like open-ended survey responses, emails, chat logs, online comments and tweets. And AI sentiment analysis and entity recognition help convert this into quantitative data. Then chatbots and virtual interviewers. AI-powered chatbots can conduct large-scale surveys or interviews. They can ask follow-up questions dynamically. They can handle thousands of participants at the same time. And what is the use case? Is that it is used for public opinion polling, for market research, for healthcare intake service, etc. The API integration and data aggregation. AI systems can connect to various APIs. API, Google Trends, in order to automatically pull massive data sets. So AI helps organize and standardize data in real time. And when this is used to, or when we want to monitor global disease outbreaks, for example, or the stock market sentiment or climate data. The computer vision visual data, image and video recognition models collect and process visual data at scale, whether it's about facial recognition or object counting in satellite images or behavioral analysis from security footage. And when we use this, we use it for wildlife, for example, population monitoring, urban development tracking, etc. There are many innovations in biodiversity conservation since we talk about wildlife population monitoring. It's amazing how AI is used there. It's worth to explore this field. And data from Internet of Things we can manage now and analyze continuous data streams from smart devices and sensors in healthcare, in agriculture, in engineering. We can automatically detect relevant patterns and events. We can use it for collecting environmental or physiological data day and night, 24 hours a day. And real-time filtering, quality control, because the systems not only collect, but also filter and clean data on the fly. So they remove duplicates, they can detect errors or inconsistencies, they can flag suspicious or irrelevant responses, and this increases reliability of large-scale data. Some tools for data web scraping. Most popular tools, Octoparse, DeepBot, Beautiful Soup. The advantage is about faster extraction of structured data from web sources. And for survey analysis, Qualtrics, Google Forms plus GPT-based analysis. And the advantage here is that we have open-ended responses that can be auto-coded using NLP. So each of these tools that we explained, web scraping tools, they extract data from thousands of web pages. NLP transforms raw text into structured data. Then chatbots conduct scalable real-time surveys and interviews. APIs can pull large data from digital platforms or services. Computer vision can extract info from images and videos. Internet of Things gather continuous real-world sensor data and quality control finally, which ensures high data accuracy at large volume. The best AI-powered tools for web scraping, DeepBot, I mentioned before, which can scrap new sites, product pages, and forums. Scrappy, ParseHub, AAP5, and Octoparse. It's a visual scraper with intelligent features. It is used with entry-level users scrapping product or real estate or job listing data. GPT plus Selenium and Playwright. And of course, we have, very interesting, the AI libraries for post-scrapping data analysis. Once data is scrapped, we use AI libraries to process it. Spacey, here we can see the name, the entity recognition, text blob, transformers, which helps with sentiment analysis, with summarization, with classification. Beautiful soup plus GPT, which helps with structural parsing, which is followed by intelligent data extraction. So before using any tool, or before you buy any tool, it's very important to check the strengths, the weaknesses, the positive and negative points. Check, first of all, if it helps with what are the capabilities, if code is required. Here you can see for its text, for its tool, we can see here the capabilities, the code required, and what is happening with data, how they handle structured and unstructured data. AI plays an important role, as I mentioned before, in pre-processing clean data. With missing value imputation, we can intelligently predict and fill in missing data based on patterns in the data sets, using, for example, regression or deep learning. It helps with outlier detection, machine learning algorithm identifying a flag anomalous or erroneous data points that could alter analysis, and the noise reduction, because AI filters out irrelevant or redundant data using statistical models or clustering techniques. Then after the data cleaning, we have the data transformation. And what is happening here? AI automates the scaling of data, for example, min-max scaling or z-scores, for better performance in machine learning models. So standardization and normalization, and then data type conversion, because this automatically converts formats, for example, text to numbers or data to timestamps, in order to make data sets consistent. Then we have text and language processing. AI can parse and tokenize. We want to explain about tokenization. Can tokenize and lemmatize text data, detect language, and remove stop words. Sentiment and entity recognition, because AI identifies meaningful phrases, topics, or emotional tones in textual data. This is very interesting. Data integration, we have record linkage, because AI matches and merges records from different sources, even with inconsistencies in format or labeling. And deduplication, because machine learning helps identify and remove duplicate entries more reliable than rule-based methods. AI processes images by resizing, denoising, detecting objects and features, transcribes audio data and removes background noise. And then we have automation efficiency. Why? Because AI frameworks like AutoML or Data Robot, so intelligent pipelines, create end-to-end automated workflows for data preparation. And what is the scalability? That AI handles massive data sets across distributed systems far more efficiently than manual or rule-based scripts. So AI transforms data pre-processing from a tedious manual task into a smart, informed, and automated process, because it improves data quality, definitely, it saves time, reduces human error, which is essential for the success of any large-scale data-driven project. The missing value I mentioned before, the outlier detection, disease scores, isolation forest, data normalization and scaling, data type inference, and correction. So it helps us with manual type casting or conversion. This model can infer data types based on patterns. We have AutoML systems. The deduplication that I mentioned, we have AI-powered fuzzy matching using NLP techniques, graph-based entity resolution, supervised ML matching based on historical merge decisions. So here the benefit is that we can handle inconsistencies in the defined formats. The anomaly correction, traditionally what was happening was a manual correction. Now we have the AI tools, generative models, which can propose likely corrections. We have reinforcement learning, which can learn optimal repair strategies from feedback over time. And here the benefit is that AI can learn from corrections to improve future clinical operations automatically. So some tools here, HoloCleaner, what is the key characteristics that it helps with the data cleaning using probabilistic inference. Three-factor Google Cloud Data Prep, another tool which helps with suggestions for data wrangling. Data Robot Paxata, it helps with automated data profiling, ML-driven cleaning. PyCaret, it's about ML-based preprocessing pipelines, and AutoML systems which help with handle scaling, imputation, and coding automatically. So now I mentioned about how NLP converted unstructured textual data into structured quantitative data. So for the text pre-processing here, the first one is what we call tokenization. We split the text into words, into phrases or sentences, then the lower casing converts all text to lowercase. We remove and stop words, filter out common but non-informative words. Then we stem or lematize, reduce words to the root form, and remove punctuation or special characters for clarity. Then the future extraction or vectorization. We have a bag of words, the count word frequency in a document. We have term frequency, inverse document frequency, which actually adjust the word counts by their importance across all documents. Word embeddings, we try to map words into dense vector space based on semantic meaning, and sentence embeddings, which generates actually numerical vectors for whole sentences or documents. Structuring data for analysis, the rows, the columns, then we apply statistical models or machine learning or predictive analytics or data visualization in quantitative analysis. And here we can see one simple example. I love the service, but the food was terrible. How it is the unstructured input and how is the processed output. Here we can see the sentiment score, the features, and the emotional tags. For data analysis, statistical modeling, machine learning, of course, differ from traditional statistics. Actually, machine learning and traditional statistical techniques are both used to analyze data, but they differ in goals, in assumptions, in flexibility, in application. In terms of purpose, sorry, in terms of purpose, traditional statistics, we have inference. We try to understand relationship, test hypothesis. Now with ML, we have prediction. We can accurately predict outcomes on new unseen data. What about the focus? Traditional statistics, the focus here is model interpretability. Machine learning, the focus is model performance. In terms of approach to modeling, traditional statistics focus on linear parametric, for example, linear regression or t-tests. Now with ML, we have more or complex or non-linear is tasks. And the assumptions, in terms of assumptions, statistics requires assumptions, normality, linearity. With ML, we can learn pattern from data. In terms of learning process, statistics use formulas and tests based on predefined models. On the other hand, ML learns from data through training, supervised and supervised or reinforcement learning. In terms of interpretability, statistics is highly interpretable because coefficients can tell you how much each variable influences the outcome. On the other hand, machine learning, it's what I mentioned before, the black box, which is powerful but less transparent, so explainability tools definitely are needed. In terms of flexibility, statistics now is best suited for small structured data sets. It can break down if assumptions are violated, but on the other hand, machine learning now can handle large data sets with many features, and it can adapt well to unstructured data. In terms of data requirements, now statistics works with a smaller data set, but needs cleaner data and careful design. On the other hand, machine learning performs better with large amounts of data. And here we can see, for an example, comparison, if we talk about how to analyze the effect of a policy, in our paper. You can use traditional statistics, linear regression to test. Machine learning here is less suitable for causal explanation. If we want to recognize objects in images, we can't use traditional statistics, but we can use convolutional neural networks. In order to predict customer churn, we will use random forest gradient boosting for machine learning. Or test the group differences. If we want to use this, then we may use classification models for machine learning or for traditional statistics, independent samples, t-test or t-square test. So here, in terms of goal assumption that I mentioned before, the data requirement and the application example that I mentioned. And what examples of AI models are used in predictive quantitative research? Linear regression, we can predict a continuous outcome based on on one or more independent variables. For example, predicting students' test scores based on study hours and attendance. Logistic regression is another AI model. We can predict binary outcomes through yes or no, or with success or failure. For example, we can predict whether a patient has a disease based on diagnostic metrics. Decision trees. What is the use here? The rule-based prediction for classification or regression. So we can predict, for example, a credit approval based on income, age, and credit history. The random forest. When it uses an ensemble model that actually combines multiple decision trees to improve prediction accuracy. So, for example, we can predict employee or attrition using workplace factors. Support vector machines. We can classify here data into categories with a clear margin. Example, we can classify emails as spam or not spam. Artificial neural networks, another AI model. We can model complex relationships in data, often used when relationships are nonlinear. For example, we can predict the customer churn based on transaction behavior. The deep learning models, convolutional neural networks, which are used for image-based predictions. For example, we can diagnose X-rays, tumors from X-rays, or recurrent neural networks, which are used for sequential data like time series or text, for example, stock market predictions and things like that. Nearest neighbors. So when we use this, predicts based here on similarity to nearby data points. So the example here could be recommending products based on user similarity. Gradient boosting machines, highly accurate predictive models for structured or tabular data. Example, predicting loan default risk with high precision. And naive Bayes, it's used, what's the use here? It's a probabilistic model used in classification tasks, predicting likelihood of purchasing a product based on past behavior. So here you can see its model, what is the main use, and the example use case that I mentioned before, the linear, we can use for house price prediction, logistic regression, binary classification, random forest ensemble prediction, neural network, nonlinear pattern modeling, XBoost, high accuracy tabular data, etc., etc. AI can assist also in identifying patterns and trends in big data that traditional methods may miss. Because it enhances pattern detection by handling volume, variety, and velocity. We can integrate multiple data types. We can adapt to real time or streaming data, something that traditional methods struggle with. We can discover nonlinear hidden relationships because traditional statistics often rely on linear assumptions. AI models now they can detect non-linear patterns using neural networks or decision trees. They can reveal complex interactions between variables that are too subtle or multidimensional for human analysis or simple models. AI techniques like autoencoders and PCA reduce thousands of variables into key dimension. Deep learning automatically extracts relevant features from raw data. For example, identifying patterns in medical images or customer behavior. We can extract insights from textual data, from visual data. We can spot anomalies, for example, in financial transactions, in network trafficking, or on sensor data, for example, fraud detection. We can identify emerging trends over time using time series forecasting and clustering techniques. AI systems can update themselves also with new data. Online learning can link static traditional models. And of course, they can improve over time, learning from feedback loops and new inputs. Some examples here, what is the scenario? The scenario is medical diagnosis. This is limited by symptom. Traditional limitation is that it's limited by symptom checklist. The advantage is that AI finds rare disease patterns in images. If we are engaged in stock market analysis, this is overwhelmed by volume and volatility. This is the limitation, but the advantage of AI is that AI models learn from historical and real-time data. And of course, the advantages of using AutoML in quantitative research, it's about time efficiency, we can automate complex tasks such as feature engineering or model selection or high parameter tuning and validation. This allows researchers to focus on hypothesis development interpretation rather than technical model tuning. And access to advanced ML without deep expertise. This opens the doors to non-specialists like economists, biology scientists to use cutting-edge ML methods. And these AutoML platforms abstract away the coding and math-heavy processes behind machine learning. It's about improved model performance because this uses ensemble techniques and optimization pipelines to select the best performing models, and often outperforms manually tuned models by novices or even intermediate users. And reproducibility standardization. This automates the workflow using structured pipelines, improving reproducibility, ensures that results aren't overly dependent on subjective researcher choices. It's about rapid experimentation. Researchers can test multiple models quickly across various data sets. So it is useful in what we call sensitivity analysis or robustness checks and explanatory phases of model building. Built-in interpretability. Many modern AutoML systems provide feature importance plots or sharp value explanation or visual tools to interpret models. Handles structured data efficiently, especially beneficial for tabular data, which are common in quantitative fields, economics, in finance, and healthcare. And it works well with structured data sets like panel data or time series and survey results. Scalability integration, because AutoML tools can scale across cloud platforms and handle large-scale data sets, and easy integration into existing science workflows. So an example of these use cases, economics, for example, AutoML application can help with forecasting inflation or employment using mixed methods. For finance, these applications AI can be applied in the credit scoring, fraud detection. In healthcare, we can predict patient outcomes from EMR data. In education, we can model student performance based on demographic and behavioral data. In social sciences, we can classify survey response and sentiment analysis. Definitely, of course, be careful of all these limitations about the blueprint that I mentioned before. Some models may still lack interpretability. The data proportions still matter. Remember this quote: "Garbage in, garbage out." If you have bad data, this is not possible to be fixed. Overfitting risk, especially in small data sets, this generates overly complex model and less control because this may not suit highly customized model requirements or novel methodologies. Neural networks also, rather deep learning models, can be integrated into quantitative analysis to capture complex patterns, to automate feature extraction, and to improve prediction and classification tasks that traditional statistical methods struggle with. So AI predictive models in place of traditional techniques. We know the traditional ones, what is happening. Neural networks now can capture nonlinear relationships, interactions, or higher order dependencies automatically. Deep learning alternative, fit forward neural networks, RIMA, convolutional transformer models, the feature engineering and dimensionality reduction. When we use this, when we automatically want to learn useful representation from raw data. The models want encoders, the feature synthesis. So the benefit is that we have more expressive features that can improve downstream analysis or ML performance. Time series forecasting and pattern recognition, when it is used for financial forecasting, for demand prediction. Some models here, Tumble CNN, a faster alternative for time-based patterns, which is better handling. It helps with better handling of lag effects of seasonality, long range dependencies compared to RIMA or similar regression. Image and text analysis, quantitative context. Here, the benefit is that we can enable quantification of quantitative inputs for inclusion in statistical models. The causal inference augmentation, which is used when complex observational data sits here, we have confounding interactions that we have difficult to model. So this improves the validity of inference in non-experimental data. And integration with statistical models. So neural nets Bayesian neural networks, deep mixed models where neural networks handle nonlinear parts, mixed models capture hierarchical structure, etc. The visualization, we have saliency maps for visualizing model decisions on images. We have sharper line, which explain neural network outputs in ways that are statistically interpretable. And the benefit here is that we can make deep learning models more compatible with explainable quantitative analysis. An example of a workflow, you have the raw data, this is the pre-processing, then you have a deep module which does the feature extraction or prediction, then you are doing the quantitative analysis, we incorporate deep model outputs into statistical models, and then interpretation. Tools like a sharp or line are used for insight, additional statistics for hypothesis testing. So the application area and what a neural network, what is the role of neural network? Is what we mentioned right now. And the data analysis and modeling, we have some amazing machine learning platforms like Data Robot, Azure ML, AutoML, Google Cloud. For statistical analysis, AI-powered notebooks can automate test linear multiple regression, factor analysis. For interpretation, insight generation, we have large language models which can significantly enhance the interpretation of statistical outputs. How? By automating, by translating, by contextualizing complex statistical results into clear, accurate, and human understandable explanations. So these models, LLMs, can take raw statistical outputs and turn them into natural language explanations. They can interpret model coefficients and results. They can automate report writing. They can identify assist statistical inference. They can cross-validate results, and they can explain model assumptions, and they can act as an on-demand tutor, so teaching and learning aid. The advantage, when we talk about language simplification, this helps, this makes complex results accessible to non-experts. In terms of speed, it's about rapid summary stuff creation. In terms of consistency, we have standardized phrasing and logic. In terms of contextual adaptation, this is tailored to audience. In terms of error reduction, the impact is that AI flags poor practices or misinterpretations. AI tools can accurately translate technical findings into layman-friendly insights. The strengths of AI in translating technical findings, it's about natural language generation. Tools like Gemini, for example, or Claude convert statistical results into plain language. They can summarize complex data into simple key points, and so they can generate executive summaries for non-technical audiences. They can help with contextual understanding because modern AI models are trained on a broad range of technical and non-technical texts, allowing them to understand the purpose of a study, to reframe technical terms using analogies or everyday language, to tailor tone and detail based on the audience, so for example, policymaker versus general leader. And helps provide insights in multiple languages, create visual summaries. The limitations, of course, and considerations have to do with lack of precision, because AI may oversimplify, potentially leading to misinterpretation. Important nuances might be left out unless explicitly prompted. The dependence on input quality, if the original data or interpretation is flawed, then the AI output will reflect that. But I said before, remember, garbage in, garbage out. And bias of hallucination, AI may generate plausible sounding but inaccurate explanations if not grounded in real data or prompts. So what are the best practices is to always double check AI generated summaries against original findings, to always provide context-rich prompts, and use hybrid workflows. And the visualization and reporting, what AI tools can assist in visualizing complex data. We have some most popular tools, Tableau with integration, Power BI, SAS Visual Analytics, Data Robot, ClickSense, Zoho Analytics. Several tools can assist in visualizing complex quantitative data, helping users to uncover patterns, insights, and trends. So have amazing tools that we use also ethically and with caution, and generate visualization, of course, improve understanding of statistical results because they help with clarity and simplicity, with pattern recognition, with customization and interactivity, with automated annotation, with real-time updates, multivariate analysis, because we can handle high-dimensional data and produce visualizations like heat maps or PCA plots or dimensional scaling, aiding this way in the understanding of relationship across many variables. Narrative integration, because AI can combine data visualizations with natural language summaries through tools like data-to-text generation, and this creates a more comprehensive and understandable report of statistical findings. And of course, the limitations of relying on automated tools, that would be the lack of contextual understanding, the data quality dependence, the limited flexibility, the lack of transparency, and false sense of security, etc. So the validity, reliability, these things are very important. And how we can ensure this by ensuring the data quality, cleaning pre-processed data, remove outliers, handling missing values and normalize features, verify always data source, use credible, consistent, and representative data sets, balance data, avoid biases that can distort AI outcomes. Then you should validate the AI model by using cross-validation techniques. This prevents overfitting and ensures generalizability. Then split data into training, validation, test sets to evaluate model performance. Help reduce model complexity and overfitting. Then measure and report reliability, so consistency checks, run models multiple times and compare results, apply the model on different samples or different types, and iterate reliability, measure agreement between annotators. Ensure validity, remember, construct validity, make sure AI features and metrics reflect the actual concept being studied. Content validity, ensure that the model incorporates all relevant variables and domain expertise. Criteria validity, compare AI results to establish benchmarks or expert evaluations. And use always interpretable models, clearly describe the model's architecture, input features, decision rules, and document all pre-processing steps, parameter settings, evaluation metrics. Use robust evaluation metrics. This means go beyond accuracy. You can use precision, recall, depending on the task, evaluate the model in different subgroups to assess fairness and generalizability. Share code data and other parameters where it's possible. Use version control, environment tracking, publish a detailed methodology so that others can replicate your study, reproducibility. Perform regularly algorithmic bias audits to detect unfair outcomes across demographic groups. Try to ensure ethical compliance with AI governance standards and data privacy laws. Involve statisticians, ethicists, and other professionals to interpret results correctly, so collaboration, validate whether the AI model aligns with real-world phenomena. The peer review, submit for peer review and encourage external validation on dependent data, and if it's possible, participate in competition or benchmarks to compare your model's performance. So, of course, the ethical considerations are there, ethical issues that should be considered when you use AI for handling sensitive or personal data. I can tell you an example of this dilemma. Maybe you want to conduct, let's suppose, a research on social media profiles, okay, using AI. Social media profiles are publicly displayed, but they contain sensitive information, contain personal information. So it's ethical or unethical to conduct this research, to use AI tools and social media profiles, which are publicly displayed, but they contain personal information. What I want to say is that throughout your research journey, you will encounter many ethical dilemmas like this. Always to be in contact with the ethical review boards, the ethical committees, to always have in mind to check what is acceptable for the journey. For example, not all journeys allow the use of AI tools. If you want to use AI tools, then you need to mention this in a specific section of your paper. For example, that would be the method section. You need to make a citation, a reference in which tool you used, and if it's possible, to copy-paste, extract to prompt, because if you give, for example, to ChatGPT a prompt, it will give you a question, it will give you every time different answer. So be careful about these ethical issues, about transparency, explainability, the moral responsibility, the ethical dilemmas that I mentioned, data quality and accuracy. The bias, of course, are introduced usually through sampling bias, label bias, we have a feedback loops. We have many kinds of bias. One, for example, the data is used to train or test an algorithm. Isn't representative of the entire population sampling bias? When human annotators who label data may bring their own biases. This is a label bias. The feedback loops, because AI systems deployed in real-world settings may reinforce existing patterns, creating biased data for future training, or measurement bias. Differences in how data is collected across groups can distort algorithmic interpretation. And of course, how to mitigate data bias by diverse representative data sets through pre-processing techniques. So try to rebalance data sets through techniques like weighting, sampling, or synthetic data generation to reduce bias through fake algorithmic design, incorporate fairness-aware machine learning models that optimize for both accuracy and equity. Human oversight, keep humans in the loop for critical decisions and regularly audit outputs for ethical and social implications. Diverse teams also are more likely to spot potential sources of bias and consider broader ethical impacts in design evaluation. So try to how to create inclusive development teams and continuous monitoring, of course. All this is very important. AI has been applied to solve real-world problems also in application, disease prediction, in healthcare, in education, in marketing, in transportation, public policy. And of course, the advantages of the great AI in educational research. We talk about education, using quantitative approach. It's about efficient data analysis, about advanced predictive model, the pattern recognition, the real-time utilization, etc. And this is a case study, and hopefully we don't have time to explain this. Okay, here we can mention that here we have the background of this study. It was the diabetic retinopathy, which is the leading cause of blindness in adults. The challenge here for quantitative research is that traditional screening methods relied on manual examination of retinal images, which is time-consuming, but researchers sought to improve diagnostic accuracy coverage through AI. So what is the AI application? That researchers developed a deep learning algorithm trained on over 120,000 retinal images. The algorithm was designed to detect signs of diabetic retinopathy and macular edema with high sensitivity and specificity. So performance was evaluated against a panel of certified ophthalmologists. It's an application. The outcomes, what is the outcomes of this AI application? That the AI achieved a diagnostic accuracy of over 90%. It showed high sensitivity and specificity. The scalability also is higher and faster results. Standardization, the AI system offered consistent evaluation, reducing subjectivity and variability among human graders. The challenges and future trends, before concluding, current challenges, methodological alignment, the model validity and overfitting, the lack of AI literacy among researchers. So we need to organize more workshops on AI literacy. And the methodological misalignment, I said before, traditional quantitative research values transparency, explainability, and many models that we mentioned before are black boxes, hard to interpret. And causal inference is not often directly supported by AI, which focuses more on prediction. So all these issues that we need to have in mind. AI models show how accuracy definitely, but they have poor generalizability if it's overfitted. Traditional research emphasizes external validity, requiring models to perform well across populations, which AI sometimes regrets. The data privacy, consent bias are major issues. Algorithmic bias can inadvertently reinforce inequality, reminding research ethics. And of course, the tooling and infrastructure gaps, the reproducibility, transparency, integration, complexity, combining statistical rigor from quantitative research with algorithmic efficiency from AI is not straightforward, because this requires multidisciplinary teams, statisticians, computer scientists, which adds to coordination complexity. And the lack of standardized evaluation frameworks, very important. There are inconsistent evaluation practices that make it hard to compare AI-enhanced studies with traditional ones. AI can transform the future of research design and methodology through adaptive research designs to enhance data collection, through advanced data analysis, to improve reproducibility, through collaborative disciplinary research, real-time and continuous research, and the skills that actually researchers need to have in order to effectively use AI in quantitative research. Of course, about programming and technical skills, about data management skills, machine learning AI concept, the communication, collaboration skills, reproducibility, documentation, and all these issues. What I need to know, but before, what I said before, any tool you need to strengths and weaknesses. And some of these tools that I mentioned before. Thank you very much.